So this is a continuation of the Star Wars project, except for Star Wars planes for some more generic World War II fighter planes, and then did some noise editing and some animation stuff. It's still not all completely finished, and the noise is not as net clean as I would like, but that's kind of the rough thing that I did. So the main things that I wanted to focus on today is adding in shadows with depth information. So that's something that we haven't done yet. And then I also wanted to add light estimation to this. And then I wanted to compare and contrast what the different things look like, because there's some things that even though they're more advanced features, they can kind of cause some visual issues. So in particular, yeah, we'll get to that. So I did an exterior recording to give you an idea of what the actual FPS is like. So a lot of frames are dropped during screen recording, so it might look a little bit more stuttery when I do direct screen recordings. And so it is a lot easier for me to do, and that's why I've done it a lot, but it does lower the quality of recording. So just to give you an idea of what it will actually look like. So I haven't actually noticed too much of an FPS drop as I add extra features in. What tends to happen is the tracking actually just gets worse. So it ends up detracking a lot sooner and a lot quicker. So it's a little bit hard to actually evaluate how maybe I should do an FPS for the web frames. That might be what I should do. So one issue that comes up is Z fighting. And so that's where you have two different 3D objects that are fighting for a position in the Z buffer. So how close it is to the camera. And when you have these two different objects that are kind of debating which one is in front, you end up with this flickering effect that happens. And so this is something that's usually really easy to resolve if you have some sort of way of distinguishing which one should be in front. So we actually can do that. But if you, Z fighting is one of those things that takes a little bit of energy to actually solve completely. So we're just going to ignore it for now. And then we might come back to it because ultimately I want these objects to be able to collide with these environments. And so if they collide with the environment, they will never actually be behind the environment, hopefully. So I would rather solve this with collision than actually implementing some sort of visual solution right now. So I've done shadows in two different ways. The first is just setting a plane below the scene, and then that will be all the shadows. And that creates these really kind of solid shadows that will work really well on solid materials. And then the second thing that I did was depth shadows. And so I used the depth map to create a mesh that projected shadows onto it. And so this creates shadows that look really nice when they're going over objects, although the depth information still isn't the most accurate piece of information. So you end up with some kind of glitchier looking shadows that aren't, there's moments where it looks really good, but as a whole, it tends to look worse. So for the depth shadow, we just give it a mesh similar to what we've done with things like depth meshes, but this time we were going to make the material a shadow material, and that actually makes this much more performant. So rendering the actual material can end up being quite heavy, but the shadow material is a lot lighter of a calculation. So that's a neat performance advantage that we get. You're using the depth API for shadows and light estimation at the same time, and you have a lot of dynamically changing lights, you will end up with quite a bit of flickering in your scene, and that's just something that happens. So both of these features are actually pretty easy to implement within the code. So for the light estimation, you basically just add in an extra light probe. You add in some extra requirement features for webxr, and then you can just get the light probe and hand it to the directional light and the light probe, and that will allow it to do estimations in real time. And in particular, it does a lot of good things with light color correction. So that's the one that's probably the most significant and kind of melds the objects in the most, like, the clearest. It actually doesn't do a super great job of the actual light direction. So there's sometimes where the shadows will be a little bit off in that way, but it does do a really good job for light coloring. For the depth information, so the calculations that we're going to be doing are basically converting that depth information into geometric information and then building a mesh out of that. We are creating a planar mesh. We are moving each one of its vertices to where it is on the shadow map. And how we are doing that is we're using some geometry. This is kind of a similar squares problem. And once we've done that, we can add in the shadow material, and that's basically all there is to it. I had quite a bit of extra footage for this one, so here's just some extra footage that I recorded.